Right, moving to the next question. This we have a system of equation 3 by 3. This is something that you should know for final exam. We talked about this briefly in a different session before, but let's just go ahead and solve this. Can somebody tell me what's the first step to solve 3 by 3 system of equation?
You can use the addition method in two of the equations to eliminate one variable.
Good. So we can use the elimination or addition method to maybe look at the first two equations and eliminate one variable. Looks like I can eliminate these easily if I multiply either of these two rows by -1, right? So let's do that. If I pick the first two equations and multiply the first row by -1, then I get -2x, -y, -z is equal to -7. So if I just simply add these two, I would get and let me see, Catherine just ask what about first and third? Yeah, you can pick either of these three equations. You need two of them to eliminate one variable. So you can make a rule of thumb if all the variables are present to pick the first two and the last two, but you have to eliminate the same variable. Okay, so if you pick the first one and the last one, you could, yeah, it just happened that two variables would drop automatically, then you can solve for z. Yeah, this happens, but that's not going to be the case all the time, as you see. So we can make a rule out of it if you like. If all the variables are present, always look for the first two and the last two and eliminate the same variable. So if I did that in this case, then I would get 3x minus 2x, that give me just x, minus y plus 2y, that give me plus 1y, or just plus y, and z drops to 0, and then that's equal to what, anyone?
2.
Plus 2, yeah. Okay, so we create the equation, two equations and two unknown. So if I go ahead and do the same thing with the last two, and this time we definitely have to eliminate the same variable. So it means I have to multiply the second row by what, anyone?
-2.
-2, yeah. If I multiply the second row by -2, I can eliminate the z. Okay, so let me give a minute to everyone to eliminate the z and see what equation do you get. And I'm gonna, while you're doing this, I want to read any other comments that you made here in the chat room. Okay, Catherine, what you made a comment here in the chat room. Go ahead and tell me, what do you mean? I'm not quite get your comments.
Well, I think that there's some problem with kind of reusing one of the equations again, which ends up kind of messing up getting the right answer. So I wanted you to talk about the strategy of that.
Okay, like I said, if all the variables are present, if we have x, y, z, as you see here, we have x, y, z in each row here, then this method always going to work. If you pick the first two equations and last two equations and eliminate the same variable, you're always going to get two equations and two unknown and solve for one of them. So let's finish this one and tell me what did you have in mind. In this case, if I multiply the second row by -2, then I'm gonna, let's copy it down here. I get -6x negative 4y, negative 2z equal to negative 18. Okay, so if I add the last two rows with the new numbers here, as you see, I have negative 6x plus 2 that give me what? Negative what? 4x.
Negative
right?
4.
And then for y, I would get negative 3y, right? Everybody? Because we're doing this, adding this to. And 2z minus z would be added to 0. We have 9 minus 18. That would give me equal to minus 9. There we have it. Now we have two equations and two unknown where we can solve for x and y. So we have x plus y is equal to 2, minus 4x minus 3y is equal to negative 9. So let me stop for a moment, make sure we can follow this method again. So if you have three equations and three unknown, we can always pick the first two equations and eliminate one variable. We decided to eliminate z here. But if you look at the last two equations and eliminate the same variable, then you end up getting two equations and two unknown, then we can solve for z. So in this case, let's go ahead and solve for it doesn't matter, x or y. If I multiply the top row here by 4, then I would be able to eliminate x. So here give me 4x plus 4y is equal to 8 plus 8. If I add these two together, 4x minus 4x adds up to 0. Then here I get 4y minus 3y, I give me y. Then y is equal to 8 minus 9, which is equal to negative 1. And somebody looks like wants to make a comment here. Anyone who raise a hand?
Never mind. Never mind.
Okay, so you're good. So y is equal to negative 1. So let me go back to. I'm looking at your comments here. Catherine, do you see this works so far?
Yes, but this is a simple one. So yeah, this one is easy. There's basically the systems of equations on the online homework were more difficult.
Okay. What do you mean by difficult is like you have a different coefficients, right? Is that what you mean? Or you mean you saw one that some variables were missing? Is that what you mean?
Well, it was first fractions, and then we were going from there.
Right. So if you see a fraction here, the best method would be to multiply each term by LCD among all those fractions first, and get it into a whole number like that first, and then continue. That's another approach. So in this case, when we find y, we can plug it back into maybe any of these equations and solve for x. So if I substitute negative 1 here, so we see x would be equal to 2 plus 1, which is equal to 3. So we find x. Now I can go back and substitute that into maybe a first equation. 2x plus y plus z is equal to 7. If I substitute for each x 3, and for each y negative 1, I can easily solve for x. So let's see. So in this case I get 6 minus 1 plus z equals to 7. So what is z is equal to, anyone? So it would be 5. So z is equal to Did you put 7 over 5? No? Okay. It will be 7 minus 5 is equal to 2. So there we have it. The solution, we can write it as a number like this. X is equal to 3, comma, y is equal to minus 1, and z is equal to 2. Again, if you see a fraction here, just multiply each term on each row by a LCD to eliminate the fraction. But for all the test purposes, these are the type of problem you're going to see on the exams and final exam. See nice whole problem, whole numbers like that, where you can easily pick up the first two, eliminate one variable, next to eliminate another variable. You get 2 equations and 2 unknown, and you solve. For the homework, yeah, we'll do some of these numbers with the fractions and decimals and all that, just for practice, of course. But for most test problems, this would be the extent of the problem that you would see on the exams. Elizabeth asking, does it matter if we eliminate x or y? As you see, doesn't make it any difference which variable you want to eliminate first. You end up getting the same set of numbers at the end. Okay. So just to make sure with you okay with this, let's see. Can I see a check mark in front of your name? If all can follow this, please.